I think we can get started. So hopefully everyone's on that's been able to click on. So we want to be punctual and get started. But first, I want to thank everyone for joining us. And I'm Matthew Cruz, and headlining this webinar is Dr. Elwyn Taylor. He's based in Ames right now. And I want to thank Dr. Taylor for being the only one of the three of us for wearing a tie, for making us look good. So I guess we didn't dress up as well as you for the webinar. So
he doesn't have to go out after this and fix a sump pump. All right. So
okay. So you got plans after this. So
yeah.
And then David Cruz, of course, is in Royal, Iowa right now, and so he'll be leading most of the webinar and asking a lot of the questions. And then I'm here actually in Mato Grosso, Brazil right now. So that's I want to send a big thank you to John Jensen, who's our director of IT, for helping get this set up and going. I guess we'll get started. And I just want to say that for people, as we go through the presentation, there's a place for you to type in questions. And if you think of a question as the presentation is going, please go ahead and type those in while you're thinking of them, because sometimes it can take a while to type that out, and then maybe it takes another 15 seconds to get to us. So don't wait until the end if you think of a question. Although we are going to go through the questions at the end. I guess without further ado, then Dr. Taylor, if you can bring up your screen share and start with your presentation, then we can go from there. So.
Okay, I should be screen sharing now. And do you see my title, by the way?
Yes, we do. Looks good on my end.
Should say 2019 Weather Outlook and Managing of Weather Risk. I'm Elwyn Taylor.
Great.
And I assume that it's time for me to begin talking. Am I correct?
You may proceed.
There you see the flood warning map that came out at 7:50 a.m. This morning, and all of the little green dashes across Iowa, or little river outlines, are the places that floods are going on. A major one, of course, going on the river over at Omaha down to Nebraska City and up to Sioux City and beyond. Pretty much setting records out there. Here's the reason. You see in the top little purple area, I've got a 9, and that's the number of inches of snow in the past 60 days up there. And you see in the light blue a 7 under the word Sioux, near the Sioux Falls area. Then most of the area had an amount of precipitation that amounted to an inch of water, but 9 inches of water if the snow melted up there in the little purple area at the top. Now, of course, all of the snow that fell during the past 60 days seems to have almost totally melted in the last 2 or 3 days. And that is what's been responsible for the flooding. Here you see a picture that's going off and on of the south part. At the top of the picture is the southern extent of Omaha. And then you see the 2 rivers joining at the bottom center of the page, which would be the Platte and the Missouri River. And you see it's a whole lot bigger now than it was a second ago, or than it is now. The little string compared to this. Also, this is in many cases the record height of flooding when we look down into this, pretty much the center of this picture of the current flood that is going on. A new record, and you see that it's labeled 40.62 feet. which is 4 feet above the old record. That doesn't mean the water is 42 feet deep. It means that that's the sea level of the top of the water. And the old record was 36.7 feet. Now it's 40.62. So essentially picked up 4 inches of 4 feet, excuse me, 4 feet of higher water than we've had heretofore there at Platt's Mouth. That's where the Platte River meets the Missouri. And so still the end of the blue in the middle of the screen down to 30, just under 36 feet now, and the little dots showing it's expected to get down to moderate by Sunday. In other words, they think that the runoff has about happened. The significant thing that went on with this was that all of that moisture that had fallen as snow melted for pretty much 90% of it in a day or two and became liquid water. And liquid water over soils that were already saturated. That is, they couldn't hold another drop of water. And so it has all had to go down the rivers or down to the floodplain. And that's what's been happening out there. Going back a little bit of history, 6th and 7th of March, the snow event that was in central Iowa. See a dark area of about the amount of snow in the center of the state near Des Moines, and the blue area going over toward the river on the right. And that's about all I want to say about the flooding. I'm going to talk a little bit about February. For the nation, you see on the left the temperature for February, and record cold where it's dark blue, and near record or much above normal where it's orange. That would be Florida up into North Carolina, and a little bit north of that going up beyond South and North Carolina. Still on the cold side of usual, below average, all of the shades of blue near average where it's white. So that would be Illinois down to North Texas, and a little bit warmer than usual in most of Texas and all of the southeast. The precipitation running above average just about everywhere except in Wyoming and western Nebraska where it was dry. It was wet in Arkansas, the state. What happens in Arkansas in February and March usually happens in Iowa at planting time. So this is the time of year we're watching Arkansas carefully to see if they are going to be a wet state or a dry state for this next 30 days. Then the pattern tends to move north about the time we're getting into field preparation and planting time. Just a couple of things that are going on. This happens to be the Waterloo, Iowa history. And 2018, way over to the right, you see a little teeny blue dot down below everything else. That means that we had a cold beginning, but one of the 3 coldest since records began in this Waterloo area in 1895. And so the little blue dashes you're seeing are the first day of each year, the January the 1st. Sometimes it was up near 60 degrees in the center of the picture, sometimes below zero for the daytime temperature. I don't see much of a trend, except that it's more variable now than it was in the center and left-hand side of the picture. And we're going back into conditions more similar to the center of the picture over the 1950s, almost as we speak. The start of the year, this was January the 1st, has very little to do with the crop year. Usually by mid-April, we have some notion as to how the crop year is going to be going. That is, the semi-stationary highs and lows around the planet are coming into their position that kind of dictates what the general weather will be for the coming season. There is some significance to soil moisture being at capacity at the start of the year, especially west of Interstate 35, north-south through Iowa, and then goes over down to Kansas City and heads down to Texas. Interstate 35 is really the demarcation of what we call Western Plains weather and Eastern Great Plains weather. It does divide right on Interstate 35. People often ask me, why does the interstate cause the weather to change? It doesn't so much. It's that they put the interstate right where the big change in the weather was, because where the type of weather you have makes its change, you have the greatest variety of plants, and usually that indicates it will be a productive area. That's where the cities grow. They connect them with the interstate, and then it looks like the interstate is causing the difference in the climate. The total precipitation for Iowa during January 1st to December 31st of 2012, the last drought that we had in the Corn Belt, is on the left. And I just want you to look at the left-hand map of Iowa, the extreme left ellipse you see says that year there was 23.18 inches of moisture fell, and in the upper right corner, 25. Now compare that with this past year, 2018 coming into 19, but 2018 we had 43 inches instead of 23, 20 inches more. In the middle of the picture, 51 instead of 22, and in the upper right, 56 instead of 25. And this was sort of the picture across the state of Iowa and for some of our neighbors. We went from a year that was dry, but had its 20 inches of moisture. I think that was significant, that even though it was a dry year and tended to, some areas came out as a drought, meaning that the yield was reduced down to 90% of normal yields per acre. 10% below normal yield is by law considered drought conditions, whether it's caused by floods or by droughts or by early freeze or late freezes in the spring, so forth. They always call that legally a drought if it has cut our yield to 10% below trend. That's the way the government works. And 10% below trend for your county entitles your county and all adjacent counties to whatever the USDA has that year for drought relief. But I wanted to compare the year with about 20 inches or a little over precipitation, which is the minimum amount, 20 inches that we can have and be able to expect a near trend line yield. And in some places it was, some places because of the hot summer, it was drought conditions officially. On the right, we are well above that 20 inches that the plants require if they're going to come out with an average yield. And you've got to have something on the order of 25 to 30 inches of moisture available to have a record high yield. Well, some of the state of Iowa, up in the upper right corner of the state, not quite, a little below the corner, I've got a 60 inches. So about double the amount that is required to have a possibility of a record high yield. This would be considered basically a little bit on the too much side in some places at least. The precipitation October through December, that is October of last year, is the beginning of what we consider to be the hydrologic year. That is the year for as far as moisture available to the crop is concerned. So I pay attention at the end of 2018 to what precipitation did we have October through December, because that all went into the soil, and that was the beginning of our water accumulation to be ready for the 2019 growing season. We consider that 2019's water year began in October of 2018. Just about everywhere had on the order of 6 inches, some places 12, some places 8, some places 10 as you look around. But the 6 inches from October through December essentially took the soil moisture up to field capacity. That is, almost everyone that had tiles in place in their fields, these tiles were draining sometime before October was over and frost began to enter the soil. By the way, we had very little freezing to depth in the soils of Iowa or our immediate neighbors during this past winter that we're just coming out of now. Some frost, of course, down to 2 feet, but I didn't see any reports of freezing down to 4 and 5 feet. Sometimes the years that we have a lot of breakage of pipes and so forth are usually when the frost gets down more than 5 feet. But just about everyone ended up the water year for the beginning of this year with the soils at field capacity. That is all the water that the soils can hold. Edging up into Minnesota, up to Fairmont, we're now looking at their entire year's precipitation beginning back in I think it's late 1880s, maybe 1890, and coming up to this present year. The green are the years when we tended to be average or above average precipitation. The brown are the years that we were below. You see the little dashed line is the trend, and the trend we've been on the high side of trend essentially since the late 1950s. That's the dashed line, and becoming more so. And that is the case for Minnesota. And of course, the really wet times are the tall green spires that you see. The really dry times are where you see the white edging down into the tan. Now looking for central Iowa, this would be about the central 1/9 of the state. And it's about the same picture, except that this past year we had nearly 50 inches of precipitation, and we just very seldom, if ever, fall below the 20. That happened in the drought of '88, that you see a little white mark toward the going down toward the right-hand side of the screen, in about where the tallest green is, you see the deepest white. Also, with the extreme left, you see 1 year when central Iowa was below 20 inches since the 1890s. So always, you can almost say, in central Iowa, we have enough precipitation to have an average yield if the heat does not become excessive. That's of interest, I think, to all of us, is the center of the Corn Belt and how it has moved. If you look at the lower right of the picture area, you see it says Springfield, Illinois, 1950. That dot, it was the center of corn production in 1950, a center being that half of the reported corn harvested was north of that dot, half was south of it, or looking the other way. Half was east of that dot, half was west of that dot. And that's how the center was determined. By 1954, the center of the Corn Belt had moved a bit north, then east, and 59. It was Peoria in 1964. And the far black dot to the left and top, 2012, the last one we calculated, Iowa City, the center of the Corn Belt in 2012. I assume that it is still moving up and to the left. You can see in the shaded areas, the gold shaded map, to the left, the dramatic change. Look at the top one. See the little bit of gold that's in southern Minnesota, and in the lower left portion of the figure, you see that half of Minnesota has significant corn production now. They also note the difference in South Dakota. It's gone from a little bit of corn production in the top picture to a significant amount. And Nebraska has also strengthened a bit. Both irrigated and non-irrigated corn has strengthened there. So the changes in the Corn Belt since 1950 up to 2012 shown in this picture. And this is an interesting thing because the Corn Belt shifting to the north and the west isn't because the farmers wanted it to do that so much as the weather made it possible because of the increased precipitation on the west of Interstate 35 and the precipitation pattern moving to the west and the north to have sufficient or excessive precipitation for the production of corn. Weather favorable for corn production has become consistently favorable in the past few years. West central Iowa, Lamar's. And here is their history from before 1900. And you see how things have improved there. You still see some drought conditions. That's below the horizontal red line. And I put a star on the drought of 1988, which the star is actually on 1989 in the picture. That's when the 88 drought reached western Iowa. It only reached to about Interstate 35 in 1988. In 89, the drought was west of Interstate 35, but had disappeared essentially east of there. And but you can see the improvement. There's a faint dotted line above the red line in the midst of the data showing that now they've reached an average precipitation for the water gear of 30 inches in the area around Lamar's, Iowa, the sort of the northwest part of the state, in a very productive area, an area that's become increasingly productive, moving from an average of near 25 at the left-hand side and quite often falling below 20 when we know that it was impossible to have an average yield or above. So things that have been happening there. I may have lost my sound, it looks like.
No.
See if we can get that back.
You're fine on my end. I hear you just fine.
I hear you just
You
fine.
still got, can you still hear me?
Yes.
Yep.
Okay. That's good then. You note the improvement from 25 on the left to above 30 on the right of this graph is basically the improvement that has allowed the production to become as good in the western parts of Iowa, really, as it is in the east. If you'd asked me 20, 25 years ago, will the highest yield per county in Iowa ever get west of Interstate 35, I would have almost chuckled. And now, quite often, the highest producing area is in western Iowa. If you would have said that Minnesota could be the top corn producing state in the Corn Belt 20 years ago, everyone would have chuckled. But now that just happened 4 years, and it's going to happen more often. Nowadays we would have to say that the Corn Belt has pretty much, as the top states, dropped out. Indiana, and it now becomes, instead of Indiana, Illinois, Iowa, it becomes Illinois, Iowa, and Minnesota. The increase in rain has shifted the Corn Belt to the northwest. And of course, are there any downsides to that? Yes, there's highly erodible places in western Iowa and the immediate neighbors. And of course, it increased occurrence of flooding with the increased precipitation going on in that area. The precipitation increase during the past 100 years is particularly of note if you look at the southern half of Minnesota and of South Dakota, and you see the large black dots. 20% increase in annual precipitation. You look over the same period of time, there's been a 5 to 10% increase in Iowa and in Missouri over that period of time, and also in Illinois. Look at California, they've done nothing but diminish 10 to 20% in their annual precipitation since we started keeping records a little bit before the 1900s. California's got consistently drier, and you hear them commenting on that in California. They began noticing this back about the time Hoover Dam was built, and they asked for a good solid share of the water in gallons or acre feet of water, and where all the other states divided it up into percentage. Utah have a percentage, Arizona, Nevada, and actually Mexico gets a percentage from the river. But California said, no, we don't need one of those percentages. We want fixed number of feet of water or inches of water. And so they went with that. Lately, some years, the river doesn't produce as much water as California's amount. And so the next year, if the water amount comes up, California's deficit has to be made up before the other states get anything. Kind of an interesting deal when we talk about California. Leaving California, going back to the Corn Belt, the precipitation does continue to increase in most areas. And people say, what will climate change be doing to that? It looks like, at least in the short run, meaning the next 40 or 50 years, it keeps the precipitation increasing, at least slightly, in the Midwest. Any increase in precipitation is likely to impact flooding. The corn yield for the U.S. Since 1988, extreme left red dot was the last significant drought previous to 2012. The two significant droughts during the time that this graph shows. Below the trend, this happened occasionally. Remember, it is not legally a drought unless the yield is 10% below the graph, and because that is the legal definition of a drought, is on a county by county basis, is yield being cut to 10% below the trend for that county. We did have an interesting situation that you see about in the middle of the chart, slightly to the right, of 7 years of above trend line yield with two very high ones. followed by 1, 2, 3, 4 years of below trend, and the past 5 years slightly above. These things are bringing comments from people. They're saying, are we going to be maintaining an above trend line yield? And I think the answer to that during the coming 12 years is no. We will have a drouthy condition coming in occasionally. Droughts becoming more common because they're on a 90 year cyclic situation, and the worst year of the century tends to be 89 years after the worst year for crops of the previous century. If you want to look at that, we do know for southeast Iowa, the worst year for crop production of the 1800s was the year of 1847. The worst year of the 1900s was 1936. The worst year of the 2000s, it would likely be 2025 for a year or so, either way of that, because this has an 89-year gap between the really bad or Dust Bowl-like season years. And we've been able to follow this back for about 600 years with tree rings, at least for Iowa and our immediate neighbors, that the worst year of the century, 89 years after the previous worst year. And it might be 88 years, it might be 91 years, but it averages 89 years. The November 1st release of the corn yield for 2018, and I put some light blue lines right through the middle of the chart, and that comes out about Iowa City for the center of the Corn Belt. And in each of the divisions is about a fourth of the corn production. And you see the red areas, particularly last year. Look at Michigan, 166 bushels, record high yield. South of Michigan, Ohio and Indiana, each with a record high yield. Tennessee and Kentucky and Alabama with record high yields, a north-south line of record high yields. The Illinois, of course, had a high yield record, and so did Nebraska and South Dakota. Still leading, as it always does, the yield per acre of corn land is the state of Washington, with its 225 bushels that they had last year. Washington always leads, and it is because most of the corn is grown on areas that much of it called the Palouse, which is really the Loess Hills area of Washington, if we were to call that Loess Hills. It is a type of loess, by the way, and a very productive area with temperatures very favorable for corn, sunshine, and daytime temperatures about as favorable as Iowa, where they grow the corn, but the season is longer and the nights are colder. And that, especially during the grain fill time, that is what kicks their yield up in the state of Washington. Soybean, similar situation, record high yields in Ohio and Indiana and Illinois and Nebraska, and of course, as I already mentioned, down to the south, but not Alabama this time, but still the Mississippi and Louisiana area doing very well. Are we having a return to harsh winters? And the answer to that is yes. The winters vary on a 60-year cycle that you see depicted here on this chart. Harsh winters are down where the red arrow is. When the blue comes down that deep, we're having a harsh winter. And of course, we'll be having another one now that's not on the chart off to the right. The harsh winters, the left-hand side of this chart of my childhood. I don't remember how many times I told my children about the mid area over the red arrow. Quit complaining about the winter. You should have seen it when I was a kid. And they just, oh, Dad. I have data. Here they are. My granddaughter picked up on that one there to the right and this past winter and said, look at that. We're having winters now like Grandpa used to have. You got off easy, Dad. And indeed, my son did, though he still doesn't believe that. This is a 60-year cycle, harsh winters being the tendency on the left of this picture, 30 years, on the right, 30 years, on the mild side up until the extreme right. This 60-year cycle apparently has a lot to do with where the Gulf Stream goes when the Gulf Stream leaves the Gulf of Mexico. Does it head right across the Atlantic, or does it hug the east coast of the U.S.? Well, if it's in one position, it'll spend the next several years working its way across to the other side of the ocean and then work its way back. And that's what gives us our round trip of 60 years and 30 years of harsh winters, 30 years of mild, if you want to look at it that way. I'm now looking at hard freezes in Florida on the left-hand part of the chart, and you see the years when Florida had significant citrus damage beginning in 1835 up to 2017. The little blue stars that you see in the graph are years when Florida had a hard freeze. The interesting thing about when those occurred, they're always associated with a La Nina, the blue icicles you see on the chart, and we were dominated by La Nina in that blue area to the left of 1980. The red area to the right of 1980 up through 2010, dominated by El Nino, the red spikes coming up, and the El Niños events giving us a 70% chance of an above trend line yield in the Corn Belt, and the blue a 70% chance of a below trend line yield. We've just switched back into what we think will be blue dominance from 2010 for the next years to get us through this period, and that is the next 40 years to get us through this period, that we'll have the volatility of yield increasing. The weather has an interesting stress pattern that you see here. I call this a sawtooth pattern, from the red showing the harshest years and for days, number of days in the year when the temperature went over 93. 93 is where temperature itself begins to hurt corn. And temperature of 87, the corn can be hurt, but it's from the excess water use or water need, rather than from the temperature. When the temperature goes above 93, the temperature itself, as well as the water use, can hurt our crop. Well, the number of days at temperatures over 93 diminished as you look at the red chart from the Dust Bowl years, 1936, 1937, and 8, to the right-hand side. And then we see this whole thing repeat, starting off rather abruptly just after we would get off the right-hand end of this chart, do the whole thing again. It becomes abruptly up to the extreme and then tapers off. The blue is the harshness of winters. And yes, we're due to have, when we have the harsh winters is also when we have the hot, harsh summers. Sort of a uncomforting chart when you realize it's about to repeat from left to right, starting essentially now, with a left to right going into this area off of the screen. The water year of central Iowa has not had a year with below 20 inches of available moisture in the central Iowa crop reporting district in the record time here that we have since 1950. It did have, of course, back in the Dust Bowl, but it's rare for us to have below the 20 inches, remember the 20 inches is required to have a trend line yield. We've had the moisture every year to have a trend line yield if the temperatures didn't hurt it. It also affects the heating for houses and buildings. The end of the blue arrows are the years when the cold winters, high heating bills, the red arrows, warmer or not as cold winters, and the lower heating bills. Goes through another cycle, these including the months of December, January, February, March for heating requirements. An interesting map of the counties. We have this for the whole Corn Belt. You click on a red dot if you go to this under this Illinois station, brought to you by the Extension Services of the Corn Belt, and you click on that red dot in your county if you want to know what the yields are typically of your crop, such as the corn or the soybean. Here's the soybean yield for Martin County, Minnesota. You can just, in the upper left corner, click the other little dot in front of corn, and there's their corn yield trend that you can see for the past 30 years. If a farmer has this, you can know that if we have weather a lot like a past year, you go here and see what the yield came out that year as differing from trend, and that's what it has a 70% chance of doing again this year on both the good and the bad years. And it's what a lot of farmers and other people call using the analogous year or the analog year to what's going on in a current year. We always try to identify that. We seldom can identify it before we get into the end of April, the 1st of May. And then we have graphs that you can make or have your 12-year-old make for you, since 12-year-olds are better at computers, it seems like, than fathers and grandfathers are. And the top one, giving the growing degree day deviation from normal. The middle one, the amount of precipitation. The shaded blue area, the maximum and the minimum historically in the location that you're looking at. This example being for Fairmont, Minnesota. We have them for every county in the Corn Belt. And the bottom one, the heat stress or SDD, stress degree days, the greatest stress being the top of the blue area. The last few years are down at the bottom. These graphs that can be made by anyone, if you put in all of the things you see at the bottom here, just copy it and paste it in to your computer, and you will get the graph above. Then you can adjust it to your state, your location, and put in the years you would like to see to understand what has been going on and see what year is moved along much as this one is. That can be helpful. Also, get the map. You see where to get it at the bottom of the page. yourweatherservice.com hasn't got anything to do with the National Weather Service, but it gets you the chart by cities that have an airport nearby, as the airports take these data. And for Waterloo, Iowa, the annual precipitation is 34.49 on the average, and the wettest month is June or July. The high temperature, red line, low temperature, the nighttime temperature, blue line, about 20 degrees colder at night in July than in the day. The colder the night is with relationship to the high temperature in the day, the higher the corn yield, and also that tends to make the corn yield higher than the USDA would estimate if you're paying attention to when we're getting especially cold nights in July and August, by the way. Heat stress begins usually when the temperature goes over 86. That is because every 10 degrees doubles the amount of water that the crop needs. If the temperature every day went up to 74 degrees in the week before silking, the crop would use the crop use in inches of water would be about 1. Up to 84, about 2 inches would be used during the week. If it went up to 94 degrees, would use 4 inches of water from your field during the week, which if the water's there, it's still a challenge for the plants to draw that much, 4 inches per week out of the soil, but possible. Every 10 degrees warmer doubles the amount of water that the crop needs. That's why we start getting in serious trouble after the temperatures reach 86. And here's another chart you can make if you wish, that tells you what the nighttime temperatures, if they were cooler than usual or warmer than usual, and red is warmer than usual, blue is cooler than usual. What you care about really is what's happening inside of the oval. I've got that July and August, that is between silking and black layer or maturity of the corn crop. If it's dominated by blue, as in the left in 1994, it will greatly increase the yield and always fool the USDA. It'll be higher than they think. If it's on the right, that we had August, so very warm at night, that will bring in a yield lower than the USDA estimates, and you can know it in advance. That's pretty much the things we want to look at. Remember that the droughts will be getting a bit more serious and happening more often now in the next 30 years, much as to the left-hand side of the chart, and rather than the red areas which are favorable to the right-hand side of the chart. This has a lot to do with El Nino. When El Nino is going on, the ocean is cold, that is blue. Over Australia, see the blue circle? There's just a hint of blue there. And the center circle, which is red, if the ocean is orange inside of there, or red or yellow, then we have an El Nino event going on, or to be a full El Nino, the right-hand red one also needs to have warm water in it. This has a definite effect on the yields of both South America and North America in the corn production, soybean production areas. Coming up to early March 2019, the El Nino had plenty of good yellow and orange across the ocean, but not very much blue over north of Australia. It's called a shaky El Nino, but we tend to think this will be an El Nino year. Accordingly, we anticipate that this will be another year of above trend line yield for the Corn Belt, at least slightly so. And I will leave that with our El Nino hints. I'm not going to describe what's happening with the clouds here, except that where the clouds are is where the rain can be. And look up in the Canada, and you see the United States, most of it yellow, then a little bit of green, then blue up in Canada. There on the area, that was the bitter cold that we had on the 7th of March, just recently of this year. And of course, that retreating now should give us a little bit more spring-like weather. The Iowa corn yield, our most recent drought was 2012, seen at the right-hand number, a little star on this picture. But I want you to note that the volatility of yields that we had over 1980, 25 years of yields all over the place, from near the potential yield, the black dashed line, to half of that, essentially. And we also had another 25-year period of volatility at 1940. Inside of the red brackets, we have more consistent yields. Look over 1960, look over the year 2000. Those are 17-year periods of consistent yields. We have just begun in 2012, 25 years of volatile yields that will likely include the harshest year of the century if the weather keeps doing what it's done for 600 years. If you have any questions, we have a few minutes.
Well, thank you, Dr. Field. That was excellent. I think I'm sure David has some questions, and he can jump in and but maybe take your presentation off screen share. There's the bottom there. There's that blue button to stop sharing. I think if you click on that, it'll probably take you off. So just so we can see you. But I'll hand it over to, there we go, now we can see you. I'll hand it over to David, he can ask the questions. Unfortunately, I might have to jump out of this webinar a little bit sooner than expected, but I just wanted to let the viewers know that we're going to do another presentation tomorrow with David Cruz, and he'll talk about the Ag Outlook, and we'll be sending out a separate link just for that. And we also, of course, will make these recordings. We're recording these. We'll make this available to our viewers right now that paid for it as well. And so we'll be sending that out probably by Friday in a separate email. So just letting people know that. And but back to the presentation. I'll hand it over to David, and he can go over with some questions.
Dr. Taylor, this is David Cruz. Glad to have you with us here today. Until last week, I thought something like a bomb cyclone was something to do with Iowa State football, but that's really changed that terminology. I hadn't heard that before. Anyway, we'll get into it looks like maybe it's a Nebraska football right now. I don't know. They're the one state that got hit by this weather event. Got a number of questions here, looking pretty good. Start with the first one. Technically speaking, if all the land that contributes to the Missouri and Platte rivers above Omaha were tile drained so that the land was not saturated coming into spring, how much would that have decreased the flooding?
Okay, tiles would not really decrease the floods very much, a little bit. When the soil has more water than it can hold, it drips out the tiles. If it has all the water it can hold, it does not drip out the tiles. It just stays there till a plant removes it. The difference between that is about an inch or 2 inches. The soil can typically hold in the top 5 feet, about 2 inches of plant available water per foot of soil. In other words, 8 to 10 inches of water in the top 5 feet of soil. Remember, it takes 20 inches to have an average crop, so we have to add some water to the soil to get us through the year, even with our best soil areas.
Okay. Next question. How do you see the wet and saturated soils affecting corn acres planted in 2019?
Because the soils are essentially saturated, and the excess draining off. Everyone that I've talked to that has a tile in their field has pattern tiles in their fields to tell me that they were running sometime between October and now, meaning that was getting the water in excess of what the soil can hold. In other words, taking it out of the waterlogged condition into a saturated condition, which is where the water will just stay until a plant removes that water. I consider the soil like a large sponge sitting in my hand. If I have the sponge sitting in my hand, it will hold water. I could squeeze some out of it, or the plant roots could take some of the water out of that area, but it won't drip anymore. When the little air pockets in the soil become filled with water, then we're beyond saturation, and we have a waterlogged soil. The tiles will take care of that and let that free water that is in those air compartments drain out.
Here's a related question. When will farmers in northern Iowa, southern Minnesota begin planting corn this spring? Will planting there be normal or delayed?
Right now, we can't tell. The patterns are just coming into place. If you want a real hint at that, just keep track of what's happening from now and the next month in Arkansas. If Arkansas is running wet, that wet pattern will likely be on top of us right at planting time. And so we go to Arkansas now and follow them for a month, and remember that what's happening in Arkansas at the moment is usually here in the center of the Corn Belt. A month later, as the winter patterns withdraw back up into Canada, it moves Arkansas right over Iowa, Illinois, and parts of Nebraska and the Dakotas.
Next question. The 90-day SOI was a negative 5.6 last week. The monthly SOI was a negative 13.48. Is that El Nino? And how important is the SOI to determining El Nino La Nina conditions for the Corn Belt?
The SOI is the way we determine it, and it becomes significant, and you can count on it with its 70% chance of above trend line yield when the value reaches 8. And as you saw, it's about a little more than halfway there. When we're in La Nina, it changes sign. So we go from positive to negative back and forth, but right now 5 is more than halfway, 8 being a strong El Nino. They're calling it an El Nino, but calling it a weak or a faulty El Nino at the present time.
Yeah. Here's a question. I live in west central Minnesota, 70 miles west of the Twin Cities and 18 miles north of the Minnesota River. We have had 5 of the last 6 years. We've had 1 month with a foot of rain last year, June, which drove down yields. My corn was 51 bushels per acre less than in 2017 at 178. Will we continue this trend until the 90-year drought cycle? How do we get USDA NASS to understand that too much water is just as bad as too little and reports the yield correctly and not wait to make it up in the March-June stocks report when the stocks aren't there and they have to say we reported too high a yield? No way Minnesota averaged 184 bushels, much less a single county that made that level last year. We were on the northern edge of the highest water pressure. Guess you'd like a comment on that.
Those are good observations, and I would just comment that yes, the difference can occur if we're having a wet year or a dry year, and remember, too much water is just as big or bigger problem with the soil than slightly to the too little side. Ideally, if you've got drainage in your soil, the tiles take care of that. That is why it has been so important. If you can get the crop established and you have good pattern tiling underneath, it does allow enough of the excess water to get out that air can get into the soil. Remember, oxygen is just as important to the roots of the plant as oxygen is to an animal. The green part of the plant uses carbon dioxide and doesn't care so much about the oxygen, but the roots have to have oxygen. That means you have to get the air spaces filled with air in the soil, not filled with water. That's why tile works.
Okay. I think the next questioner would like a little confirmation. He says, did I understand you correctly? The Corn Belt probably will experience a weak El Nino for 2019, which means not record corn yield?
And El Nino is a 70% chance of above trend line yield. It doesn't say anything about weather records, but you have to be above trend to have a record. The La Nina goes with below trend line yields being likely, and it's also very close to a 70% chance of a below trend should we move into a La Nina. As long as we're on the side like now, about 5, that's not fully qualified as an El Nino, but at least it's a good distance away from La Nina, and we consider that to tell us, well, the way it's looking now, if everything stays the same, we'd expect a bushel or 2 above the trend, about like we had the last couple of years, as different from trend. If we get into a full value gets to 8 on that SOI, then we increase the odds of being full 5% or more above the trend and what we would call a very large yield.
Here's the next questioner. Weather events appear to be becoming more intense. What does this say for the predicted drought ahead? Does climate change impact the intensity of the drought?
This climate of getting the winters more intense now is the 60-year cycle. It has to do with where the Gulf Stream flows across the Atlantic. When the Gulf Stream leaves the Gulf of Mexico, does it head for way over to Portugal, or does it hug the U.S. coast? And If it's hugging the U.S. coast, it'll start working its way to Portugal and take about 30 years to get there, 30 years to get back. And in the meantime, that will change the effect of what's happening in our winters and Europe's winters. Yes, when we're having 30 years of harsh winters, Europe's having 30 years of mild ones, and vice versa. It tends to be controlled more than any other single item by where the Gulf Stream flow is going across the Atlantic.
I think what the commissioner was looking for was whether actually, we're seeing all these intense events like this record flooding, and it seems like constantly we're getting, record fires or whatever, and everything seems to be more intense, setting records. And what he's asking is that this drought cycle ahead, does climate change impact that any? I mean, does that mean that is it possible that if this drought is like the one in the 1930s, that it's even worse because of climate change? Or does it have little impact on that?
Some of the people that are studying the changing climate caused by especially the percentage of carbon dioxide in the atmosphere, say that it should wash out the effects of some of these cycles. And I wouldn't disagree with that, except that so far we haven't seen any of that happening yet. The human-caused climate change, I think, is beginning to be detectable and understandable, but still these big things affecting crops are the cycles that we've been experiencing, and I think we're probably still a few years away from when human-caused climate change will begin to wash out these cyclic effects that we were talking about today.
Okay. I said, where do Iowa State University climate scientists stand in the debate on climate change? I think there's a Dr. Tackle and other ones there, but are they still there that doing researching that, and where do you stand relative to that with the rest of with where Iowa State stands on climate change?
Well, Iowa State does a good job of talking about things that are real, that we've got data on, and not such a good job of passing along rumors. A lot of rumors are involved with what you hear about human-caused climate change. The scientists at Iowa State University try to form their opinions based on knowledge, and I think doing quite a good job of it. Dr. Talkley, that you mentioned, has sort of been leading this research project for the last few years. He is a retired person who still keeps working. I understand that's sort of a tradition. Also, by the way,
who else does that?
the first of the year I did retire, but here I am sitting in my same office at the university, just not being paid by the university to be here, but they still let me come in and do things like this broadcast.
Okay. Based on climate change models, where's the best region of the Corn Belt or Canada to buy a farm?
Okay, repeat that for me, please.
Based on climate change models, where's the best region of the Corn Belt or Canada to buy a farm?
Okay, the changing climate that is going with the warming, basically, of our planet does not have an immediate detrimental effect on the Corn Belt. In fact, the theory of the thing, as well as the observation, is that we have a buffer in the Midwest, and it will take some time before the negative effects catch up with us. And maybe the greatest negative effect will be the increases in precipitation becoming excessive and more floods occurring before the climate change and the warming actually sets us at a deficit and too short of water for our Midwest area. And I think that is probably the general consensus of everyone that's done research on this, that the U.S. Corn Belt is in an area that would be about the last place on Earth that would be really detrimentally impacted by a heating planetary temperature.
Very interesting. Let's see. I'm looking through here. Some of these questions that are popping up here have been kind of answered. Don't want to miss something though. Another one on West Central Minnesota again. I've installed 180 miles of drainage tile over the last decade, but ditches and rivers get full and water stays in tile, so no advantage with such heavy rains. Will that continue until the drought cycle, till the 90-year drought cycle?
We'll continue probably to have some years, even through the drought cycle, that have excess water, extreme years, because the drought cycle is in an extreme weather climate part of time. Remember, the tiles don't put a whole lot more water in the streams than if they weren't there, because once the swamps and the little lakes are full, and we get more rain, it's still going to go down the rivers. Now we just take it down a little in advance before they becomes a pond. It is taken out as excess water in the soil, but it doesn't have a real great effect on flooding. So a lot of people are of the opinion that tiles in the soil can cause the flooding, and that is a very minimal part of the flooding, by the way, compared to what you would have on the same land without the tiles in it.
Okay, I think one more confirmation here. It says, are you still thinking the next major drought will occur in 2023, 2025?
And so right now, our estimate is that our trend will continue on about the same slope of increased yield. And of course, in summary of today, we again expect another year with 2 or 3 bushels above trend. I'll be more certain on that toward the, well, shortly after tax day, I like to say, is when the weather patterns really make themselves known as to how they will be influencing our pattern for the year. And so by the end of April, I try to have what I consider a reasonable estimate of yield from the way I calculate it. And people say, is your calculation any good? I say, I don't put a whole lot of stock in it, except that it has been closer than anyone else's estimate that I'm aware of over the last 30 years.
Okay, this last question until something else pops up here. The questioner says, is NOAA and NASA right? Is the Greenland ice cap melting? Is the planet warming because of greenhouse gas emissions? Or are volcanoes cooling it, negating global warming?
All of these things, yes, and to get them exactly what percentage is a bit difficult to do. But remember, we know very well what the carbon dioxide is doing directly. The other things we're still working on, and still some of the effects of the carbon dioxide in the air, research going on with it. Just try to get your information from the scientists, not from the internet opinions.
So that means that NOAA and NASA are scientists, right?
And I worked as a scientist with NASA for quite a few years, and I still have an appointment with them as what they call as a solar system ambassador. In other words, I give a lot of talks on the item and where NASA stands and where science stands on understanding the effects of the sun on us and the atmospheric composition and these other things. And I'm honored that they consider me a person that you can look up, and I will come out and give talks. If you want to Google that, you would Google solar ambassador, solar ambassadors, solar ambassador NASA. I'm one of them.
Wow. Okay. Well, I think we have one more question that popped up here that says, will you tweet your yield estimate in April?
I try to get the statement out by the end of April and have it be not inconsistent with other responsible estimates and what you might guess if you were just looking at the trend, which side of the trend will we be on and by how much, and just it's not been possible to do a reliable job of that before the end of April, when the high and lows that persist for pretty much the summer season are in place.
All right. I think that wraps it up with Dr. Taylor. We again want to thank him profusely for joining us today. I think it was a very informative webinar. I know I learned a lot. Now I can go back to my sump pump here pretty quick. I'm not enjoying this weather just too much here at this point in time, but thank you, Dr. Taylor. I guess we're going
Yeah,
to
Doc,
go ahead, Matthew.
I was just going to say thank you to Dr. Taylor, and I don't. It doesn't look like you can ever retire because you have too many fans right now. So we enjoy your presentation and appreciate you taking the time to do this.
Now that is a point of discussion. Everybody's wondering, asking this question, that who in the world's going to replace you when that day comes, and so it's. I think we're all going to retire at that time. So that might be how we solve that. So thank you very much.
Great to be with you. I will mention that the content of this talk I consider available if people want it. I will send a copy up to your office, and if people can work with you, if they didn't make a recording of this, maybe they can copy maybe the screens that you're seeing. Remember, these things are not copyrighted, they're public information.
Appreciate that very much. We'll do that. We can handle that. People want it, just call the office and let us know. So, all right. Well, we'll be back with the rest of you tomorrow. Looking forward to that. So, and Matthew, how are things in the Mato Grosso? I guess I lost him already. So we'll talk again tomorrow.